Hello friends, today we are going to study a fundamental law of fluid mechanics, that is hydrostatic law. Let us first see the statement of hydrostatic law. It states that the rate of increase of pressure in vertically downward direction in a fluid is equal to specific weight of the fluid. So let us understand this statement by drawing a figure. Let us consider a fluid which is open to atmosphere and having some depth. Let us consider a fluid element inside this fluid. Let us name this as PQRS. Now let the area of this element be dA and height say dH. Now let us consider the forces acting on this element. There will be vertically downward pressure force, there will be vertically upward acting pressure force, and there will be another force, that is self weight of the element. Now let us discuss these forces. We know that pressure is given as force upon area, and hence the force we can write as pressure into area. Here area of the element is dA, so pressure force will be P into dA. Second force acting is weight of the element. Now weight of the element is given as specific weight, that is rho g, into volume. So rho g into volume is area into height. So it is rho g, area is dA and height is dH. Okay, now let us see the forces acting on face PQ and RS. So force acting on face PQ will be P into dA, just like this, pressure into area, and on SR the pressure force will be P plus d by P by d by H into dH into the area, that is dA. Now we can see there are two different pressure forces acting. On PQ it is PdA, and on SR it is P plus dP by dH, or d by P by d by H into dH, because in the statement itself it is mentioned the rate of increase of pressure in vertically downward direction. That means if we go vertically downward, pressure is going to increase. Now we have everything ready with us for the derivation, so let us begin the derivation. Now for equilibrium of this particular element, we will write sigma Fy is equal to 0. So I will consider all the vertical forces and equate them to 0. So let us begin with positive vertical force, which is acting in positive y direction, that is the pressure force acting on face SR. P plus d by P by d by H into dH into dA minus this pressure force which is acting in negative y direction, P into dA minus self weight of the element, which is rho g dA dH is equal to 0. So let us open the bracket. We will get PdA plus delta P delta H dH dA minus PdA minus rho G dA dH is equal to 0. Now we can see here we have positive PdA, here we have negative PdA, so we can cancel these two out. So what remains with us is delta P by delta H dH dA minus, or we'll put this thing on the other side, so rho G dA dH. So we can cancel out dA dH from both the sides. So finally we get delta P by delta H is equal to rho G, and that is our required expression. Now look at the statement again. The rate of increase of pressure in vertically downward direction. Rate of increase of pressure in vertically downward direction, that means vertically downward direction means height of the element, is equal to specific weight of the liquid, that is rho G. So this is our required expression for the hydrostatic law. Thank you.